Hi everyone. In today's class, we're going to look at solubility and solutions. This is the first lesson of Unit 4. By now, you've already heard of different types of mixtures, like heterogeneous mixtures and homogeneous mixtures. Well, all solutions are actually mixtures. So that means we have mixtures or solutions that are heterogeneous, where they don't mix evenly. So if we're looking at heterogeneous solutions, these solutions are often visible as two substances mixed together. Mix unevenly together. Okay, so we've seen heterogeneous solutions actually. A good example of it could be like carbonated beverages. Where you see a good mixture of liquid and gas. But most of the solutions that we're going to concern ourselves with are actually homogeneous solutions. So just like the definition for homogeneous mixture, these are solutions that are mixed evenly or uniform. So most of the time they appear as one state or a single phase. Even though they're basically a mixture of two substances. Often, chemical solutions that we look at appear to be solids dissolved in liquids. So these chemical solutions could be things like solid sugar plus liquid water. Okay. But when this happens, okay, and they have to be uniform, we actually call it dissolving. So a lot of our homogeneous solutions have dissolved substances in them. So often we have a solid dissolving in a liquid. So that leads us to another issue. What does dissolving actually mean? Well, in previous classes, I've mentioned that dissolving is very different from melting. Okay, to a child, it may seem like dissolving is melting because you take something that's solid and all of a sudden it's a part of a liquid, okay, or it becomes a liquid, which is actually inaccurate. So we have a different way of kind of explaining what dissolving means. So if we look at it from the molecular level, dissolving simply means, oops, particles of one substance is mixed homogeneously between the particles of another substance. Okay. This is a physical change, not a phase change. Okay. The physical properties are being altered, but it's not changing in phase. Because after all, we are creating a mixture. And of course, it's not a chemical change either, because you haven't actually created new substances. You are simply mixing them together. So a really common example is basically salt and water to create salt water. Now, salt water itself is the solution. And normally, when we're talking about dissolving, this is the substance that's dissolving. But dissolving goes both ways. Because if we look at our explanation of what dissolving is, it's one substance mixed in with another substance, okay, in such a way where it forms a homogeneous mixture. So you could say that salt is dissolving in water, but someone could also say that water is dissolving in salt, and they'd be right as well. It's just that a lot of the times we often think of the solid substance as the one that is actually dissolving. And to kind of put another term to this, we often think of the salt as a solute and water as a solvent. So you'll see these two terms here, solute and solvent. Some of you guys may have heard of solvents before, and again, some of you may have heard of solutes. But most people recognize that solvents are actually the liquid portion, okay? And people often think that solutes are always the solids. That's not entirely true, but for now, we'll kind of go with that idea. In actual fact, when you have solutes, okay, solutes are often solids, but they can also be liquids and gases. So because they can also be liquids and gases, saying that solutes are only solids that dissolves in another material is actually inaccurate. What is more accurate is that solutes represent the lesser amount of substance. Being dissolved. Okay, so for example, if we take our salt and water example, we often would dissolve, let's say, 5 grams of salt. Okay, if it's only 5 grams of salt, that means our solvent, the other substance, has to be in greater amount. Now, again, like I said before, solvents are often liquids, but they can, again, also be solids and gases. So they can be solids or gases. Okay. The proper definition of a solvent then, my apologies, is the greater amount of substance being dissolved. Okay, so in the context of our solute, if we have 5 grams of salt, okay, we can't have 5 grams of solvent. Okay, it's the same amount, and we can't have less than 5 grams of solvent. So we're going to pick a rather larger number. Okay, let's say it's 50 grams of water. Okay, now if you recall, 50 grams of water is the same as 50 mils of water. And we know that if I take 5 grams of salt, I can definitely dissolve it in 50 milliliters of water. Okay? But the fact that we have more water than salt makes the water the solvent and the salt the solute. If the numbers were reversed, if I have 50 grams of salt and only 5 grams of water, water would be the solute and salt would be the solvent. Okay? So it's always based on greater or lesser amounts of substances, because each substance can dissolve in each other. It's just that in everyday experiences, we often just find more solids dissolving in larger quantities of liquids. Now, this brings us to a situation where we have a special type of solution, okay, called an aqueous solution. So aqueous solution does actually have a state. Okay, most of the time it's represented by AQ, like this. Just like we have solids, liquids, gases, we also have aqueous. So we've considered it to be a special state or phase of matter. But in solution form, an aqueous solution is created by dissolving any solute in water. Okay, it's specifically for water as a solvent. Okay, so because water actually dissolves a lot of different materials, okay, water is sometimes known as the universal solvent. So this name is given to water because H2O can dissolve many types of substances. Oops. Okay, so for example, if we just took our salt, okay, but this time we write it like this. Okay, NaCl is a type of salt. It starts off as solid. And if we were to have an arrow like this, okay, and we add water on top of that arrow, that means water is involved in this reaction, let's say, and it goes from NaCl solid to NaCl aqueous. Having the aqueous here tells people that this is a salt solution because it's salt mixed in with water. Okay, so you're going to see this type of state quite often in this unit. Okay, it's all about making different types of aqueous solutions. So I just have a couple of other terms to go through with you. Okay, we have two other terms that are very similar to each other. Okay, well, similar to the word dissolving. Okay, and it's called soluble and insoluble. So, for example, if you have salt in water, we know that salt will dissolve in water, right? So, let's say this dissolves. If something dissolves in water, we say that it's soluble. So soluble equals dissolvable. Okay. There are two very similar words. So that means if something does not dissolve in water, so if something is undissolvable, we can also say that it's insoluble. So it means not dissolvable. Oops. And this could be used for any type of substance, whether it's a solid, liquid, or gas. Okay, so any combination of mixtures, if it's not dissolvable, we say it's insoluble. If you can dissolve it, we say it's soluble. Okay, so these words will come up again and quite often. So that's two different terms, or newer terms, I guess. There is another one that you'll come across as well. That's again quite similar to soluble, insoluble, and it's over here. So I'll just move this up a little bit. Okay. Here we have the terms miscible and immiscible. Okay. Miscible, again, it has the same meaning as soluble and dissolvable, but it's very specific to the types of solute and solvent. Okay, we use these two words when referring to two liquids. So you use these terms to describe two liquids mixed together. Okay, so the first one, in this little image here, you see some oil and you see some water. Now we know they don't mix. Oil floats on top of water. Okay, so in this case here, we say oil and water are immiscible. So immiscible meaning they do not dissolve in each other. Okay. You can also say that they're insoluble. People understand what you're talking about. But usually when it's two liquids, okay, the proper way of describing the two would be immiscible. On the other hand, when you have something like food coloring and water, okay, so this is food color and water, they're both liquids as well, but they dissolve in each other completely. Okay, so food color and water, both of these substances, let's say these liquid substances, are miscible with each other. Again, meaning that these two liquids can dissolve or are soluble in each other as well. So we'll come across a few more different terms, okay, as the unit progresses. But the ones that we've discussed here, you'll hear me use them quite often, okay, in all the other lessons. So I figured that it would be useful for you to understand at least some of the basic terms and understand some of the concepts behind them. All right, that's all I have for now. See you guys later.